will be I can only pronounce your first name, Evangelos.
Yes.
Okay. The second one, you may introduce yourself. Okay.
No worries. Hello there. Thank you very much for coming. So we're going to discuss about exploring the SAP version 10 on the UK construction industry. Let me have the clicker. Yeah, thank you. I hope this will. Okay, so briefly the agenda about this paper, why this is important, what is the standard assessment procedure, what does it mean, how it works, key changes on the SAP, and between SAP 10, which is the new, which released back in July 2018, and SAP 2012, which is the current methodology, the impact of the new SAP 10, a critical review of SAP 10, and conclusion. Of course, this is our views and through the research on the industry. We picked the biggest changes to present you here. So this highlights, as I said, the difference between the government's SAP, which is the standard assessment procedure for energy ratings of dwellings. So this is only for houses, or flats, not for commercial areas. For you who are not familiar, it was released 27th of July 2018. It was a major day that day. Probably you might remember it was the century's longest lunar eclipse. At the same time, we're not going to talk about that. We'll talk about SAP, which was released by BRE, the Building Research Establishment, and the Department for Business, Energy and Industrial Strategy here in the UK. So one of the most significant changes between SAP 10 and SAP 2012 is the alignment of the so-called carbon factors of the reality. So the gas CO2 factors, so how gas means in comparison to electricity. So the electricity has the SAP 10 introduced a 55% reduction on the carbon factors. And what we mean by that, we believe nowadays that in UK we're quite green in producing electricity, and that means that the network is as green potentially as using gas to heat, to have power potentially out of the network. So overall, SAP 10, there is no doubt that the updating calculation methodology will challenge the current design of buildings. So myself as a consultant, when I do design for building services, electrical, mechanical, we always, up to now, we were looking for things like CHPs, combined heat and power, in buildings. We're doing gas boilers because gas used to be greener. But now things probably will change. So this is a very quick, the milestones of SAP, which was developed originally back in 1992 to do a way to meter and to establish a procedure to see how efficient is our design, and all the way down to 2018 when the SAP 10 was released. It's very important here to remember that SAP is not yet is not included in Part L. Part L, which is the building regulations, talks still about SAP 12. So in the new release of SAP of Part L, we will actually see the implementation of SAP 10. So still we design with the old system, shall I call it. So what is SAP? SAP is uses BRE, which as we said is earlier established SAP with the government. Suggested to use a piece of software, like a point system, shall I call it, which depending has some key elements, as you can see, ventilation, thermal bridging, opening, space cooling, overheating, etc. And depending what kind of system you use, either you get closer to zero carbon, if this is what you have, or closer to your target according to your planning permission. So if you have a planning permission, for example, a big scheme, like a 300 flats, and in London, you probably need to be zero carbon. So to achieve zero carbon, you need to reduce photovoltaics, you need to reduce a number of things. So this is the TER, target CO2 emission rate, which is calculated based on a notional building, which means that we have let's say we have the same building. This is a typical building, and then we try to achieve zero carbon based on that building. SAP originally starts with a basis of that notional building and goes to how much more efficient you could do that building by introducing, let's say, insulation, by introducing other stuff. So, as I said, SAP10, earlier, just a little bit earlier, London GLA has actually adopted SAP10 ahead of the game. So, anything which is a greater scale, a big scale, let's see, which is, according to London GLA, is over 10 flats or 1,000 square meters covered, will need to be calculated based on SAP10. Smaller projects, like 8 or 9 flats, still can go SAP. They don't have to comply with SAP10. So once we do, again, as I said, once SAP12 will be part of Part L, then we'll change all of the carbon factors we discussed earlier, etc. So for the time being, we're still at SAP12. So like some key questions. How will SAP10 influence the approach of zero carbon technology for new homes? How significant will become adopting mature technologies, such as intelligent building systems, such as prefabrication, etc. And how, if could SAP10 trigger further innovation in the construction industry? We try to analyze this in our paper. We, again, the two procedures, some key changes are noted here. So one of the big ones is the carbon factors and fuel prices, which we'll discuss one by one later. So I'm noting the time, we need to be faster. So carbon factors and fuel prices. So as you see here, the SAP2012 electricity is 0.519 kilo CO2 per kilowatt hours, where in SAP10 is 2.33, almost equal with gas. Straight away, instead of having a gas boiler, someone can go and install, for your heating system, can install electric radiators and still will comply, or almost will comply. The shortfall is so small, we can see the difference. And you could see the trend in 2016, SAP 2016 was never utilized, was dropping down, so 0.4. The major difference, of course, is prices. So electricity versus gas. Electricity is 4 times more expensive than gas. So a developer, it's probably quicker to throw electric panels everywhere. But for the buyer, the owner of this flat, will be much more expensive to run that heating system, potentially. So that is, so we need to take under consideration not only the capital expenditure, but also the OPEX, the operating expenditure. So the other thing was configuration of PV panels. So the SAP10, SAP12 used to say that we have a block of flats, we have a PV roof, and then all of them, everybody can share it. We care as a more macro, shall I call it. In SAP10, we care about like a more micro situation, so we talk about a function. Previously, we were talking about 50% was assumed of the production of the PVs, was assumed it was used in the building. Now, there's a function of the size of the system. So there is a beta factor, which is a percentage of electricity generated by the PVs that is used in the dwelling. So that means that effectively SAP10 drives you towards the route of each dwelling will have its own small PV system rather than a block of flat which have one central PV array, which is potentially could be non-commercial. At the same time, sorry, apologies, I'll go back to this to say that at the same time, because the output, as you see for electricity, regarding SAP10, is it has dropped so much. A PV system, in order to, if you want to offset a lot of carbon, going with PVs previously would make sense because you had a 0.5. Now you need to install almost double the size of that room we would have before. So if let's say you had like 100 square meters, and that would calculate it equals to, will multiply by 0.5. Now the 100 square meters will be multiplied by 0.2. Straight away, you need to have 200 square meters in order to offset that factor, the CO2. Hot water demand, the new SAP10 calculates, goes through the process of counting each tap, each bath, each shower, and then has a factor depending on the rate of that bath, tap, shower. So straight away, it's more realistic than you used to have. So it's very good, etc. The other thing is the default distribution loss factor, which is associated with the heat networks. That affects massively what we used to have, say, CHPs. So the combined heat and power or district heating systems, which we have been installing in the past, could potentially be affected because previously we were using SAP10 assumes half of the heat generated by the system is lost in the network. So straight away, if you would produce, let's say, like 100 kilowatts of heating, now under the new system, you can take under account only 50 kilowatts of it. So again, that affects the CHP. So more or less under Boris Johnson, let's say in London, we are installing a lot of CHPs. In the future, probably will be not as desirable, the CHP network. Heating profiles. On the left, you see SAP10 and SAP12 on a weekday. On the right, you see SAP10 and SAP12 during the weekend. So the SAP10 believes that there's a difference between SAP10 believes that there's a difference between the 2 weekdays. Previously, under SAP12, you would consider that you are there throughout the day. Now we believe that this all of the week, SAP10 has been changed to apply a consistent daily pattern for all days of the week, including weekends. It's easier to read it, sorry. So that again is a change on the heating pattern when we calculate how much CO2 we produce. Regarding the lighting, the SAP10, SAP12, you will say to you, do you use energy bulbs? Yes, I do. Tick the box, that's it. SAP10 will say, is it a common fluorescent? Is it an LED? Is it a metal halide lamp? What kind of type the luminary is? So that's a much better and a welcome change to calculate more, complete the system. And then finally we have overheating. And now at the SAP12 we will say that if you open the window, then you have no risk for overheating. Under SAP10, that goes out of the window. Depending if we have, for example, an apartment on the top floor, we might consider the overheating to be a problem. So then you calculate, you need to do a more thermodynamic model to go through it. So what's the impact? The impact of the new SAP, so the changes is, the major change, as I said, is the SAP10 have 55% reduction of CO2 on electricity, 4 times more expensive, as we said, between gas and electricity. That means that we have a model which, it's both what you use, gas or electricity, is the same. We know from the government recently that as of 2025 in UK, gas is banned. So we're never going to use, for new builds, boilers anymore. We also know that we need a double size double the size of the PVs an impact because of the 55%. And also SAP10 talks about diverters. Diverters is a easy technology. What it does is takes electricity, and if you can heat water, for example, you drive an element. So straight away we have some new technologies coming in. I can see that my time is ended, so I will go very fast. The impact of new SAP, the challenges, heating patterns on this. As I discussed, the changes, better homes than before, the carbon factors and fuel prices will not really affect any dwelling emission rates, because we used to for current building regulations. And overall, talk about we would see electric underfloor heating coming in on the game, and we're going to see electric panels coming in. That could assist off-site manufacturing quite a lot, because it's easier to plug systems like that. Carbon factors, we need to be careful with this. We believed that the system has been decarbonized. We have a green grid. Realistically, the feed-in tariff's gone. The Cumbria in Toshiba and Hitachi, both new nuclear factories in Cumbria and Wales, have stopped the construction there. So we can see that we're no more nuclear for the time being. So there is a bit of a risk of the system to carbonize again. The heating, again, will change on the EPC ratings, because the underfloor heating, if it's wet, has different characteristics than electric. Lighting, metering. We believe that metering could be reduced. Metering is important. We help you with post-valuation, especially if you have electric heaters. We should have zone-by-zone systems. And then finally, we believe protecting the green belt is important, especially in areas where we have no gas, we have only electricity. That could see developments easier to meet their planning requirements rather than before. We believe in post-evaluation that every 10 years nowadays you will need to have a new EPC. How the new EPC will be based on the current SAP. If you had a building today with low electricity CO2, does it mean that instead of having an A-rated building or flat, now is D-rated flat? So how that affects your asset on price. Finally, we really think that we should invest in smart buildings. There is a British standard, the European norm is around for a while now. Talks about 18% overall saving on dwellings, breaks it down. I mean, don't get me wrong, Ithaca 7, this is what we do. We do intelligent buildings and smart homes. So we're really keen on SAP from the sustainability perspective, but we believe that there's a potential route to market for us. And finally, this is the conclusion slide, which realistically, I just think I dropped everything in, so we can have a discussion. Thank you very much. Thank you. Apologies for speaking